Integrals are equations that give you the area under the curve, and they are the opposites of derivatives. So for example, if we are given the function f of x is equal to x squared plus 2, the integral of x squared plus 2 would be x squared plus 2 dx. And to find this, we would almost do a reverse of the power rule. Bring down or add 1 to the 2, so that's x cubed, and then divide by that, by 3. So 1/3 plus 2, we add 1 to the x, and we divide by 1, 2x. And then plus c is a constant for integration, because if we were to take the derivative of this, the c would go to 0. So we need to account for the fact that the function might start a little bit higher up. But if we do take the derivative, or more accurately, find the differential equation for this, we would get 3 times x, or 3 times 1/3 is 1, 3 minus 1 is 2, drop that, 2. dy dx. And now this is the same thing that was right there. We can factor constants out of integrals. So for example, 2x squared is equal to 2 times x squared. Integrals are added together. So the integral of x squared plus 2 is equal to the integral of x squared plus the integral of 2. Now this also works with trig functions. We can easily see, for example, cosine of x. We know that if we take the derivative of sine, we get cosine. So this is equal to sine of x plus c, our constant of integration. Then if we want to find the integral of sine of x, well, that would be negative cosine of x plus c, because negative cosine, if we take the derivative of that, we get sine of x. Oh wait, no, we get cosine of x, because we take the derivative of that, we get negative sine of x. Now, we can also see with secant tangent, this is going to be equal to secant of x plus c, because the derivative of secant is secant tangent. So integrals are essentially just the opposite of differential equations. They also represent the area under the curve. To show that more accurately, it would look something like this, and they estimate the area under here almost by imagining little rectangles are drawn at all these points and calculating what the rectangles approach as we get more and more rectangles, because the more rectangles you have, the more accurate and precise your measurement is. So we see what the value approaches as we add more of those, and that would be called Riemann